Here we have a helium balloon inside a clear plastic box. It's mounted on a cart. You can see that the helium balloon is suspended inside the air, tied to a string to the bottom of the cart. The question to ask is, what happens when we actually take this cart and accelerate it forward? What behavior do we see the balloon exhibit? So why don't we go ahead and try that and see what we find out. Not only should you notice the behavior of the balloon when I push it forward, accelerate the cart forward, you should also notice the behavior of the balloon when I stop the cart, decelerate the cart. One more time. Swing it a bit. Now let's take a look at fluid flow. What we have here is a large standard garbage can, a hole cut in the bottom of them. This rubber membrane right here, which is going to allow us to push the fluid through the garbage can and exit this hole at the bottom. Let's take a look at how the fluid works as it exits the garbage can. What I want to do is actually blow this candle out that's at the end of the table. Let's take a look at that. In order to see this fluid flow, we need to add something called a tracer to the fluid. And in this case, it will be from a device called a fogger. You can see that it's producing fog. I'm going to place my garbage can right here and fill up the garbage can. Now we're ready to blow some smoke rings. Right at him. Look at you too. That is neat. Now let's take a look at a beach ball inside a high velocity airstream. This is going to blow upwards. And if I toss this in, ball wanted to stay inside of our high velocity airstream. The question is why? Well, if we consider the fact that we had a high velocity of air coming up towards the beach ball and around the outside of the beach ball, that lowered the pressure of the air around the outside of the beach ball. So there was a higher pressure outside of the airstream, a lower pressure inside of the airstream, And the beach ball tends to want to stay in a lower pressure area. Every time it was kicked off to one side where the higher pressure was, it was pushed back to the middle of the airstream where it's lower pressure. I proved that when I tapped it on the side, and also when I brought it way over to the side, and it still stayed in the airstream even though gravity was pulling down on it right there. I could always draw it right back to where it started from.
O que eu tenho aqui é uma bola de isopor e eu tenho aqui uma calha comprida ao longo da qual a bola vai rolar. Enquanto rola, a bola começa a girar e vamos ver o que acontece quando ela sai da calha. Eu já volto. Como vocês viram, a bola está girando ao sair da calha. De acordo com a equação de Bernoulli, isso cria uma diferença de pressão entre os dois lados da bola, o que faz ela descrever uma trajetória curva.
Small styrofoam ball, a funnel that is connected to an air blower. And let's prove that we're actually blowing air through this funnel instead of sucking air in. What we'll do is turn on the blower. And if I have a little bit of vermiculite here, you can see that it sprays it all around. So it's actually not sucking in, it's blowing out. I have my piece of styrofoam ball, and I put it at the apex of this funnel. You'll note that the ball actually stays at the top of the funnel. The question you want to ask yourself is why does the ball stay here instead of blowing through here like you would expect? Let's explain. What we have here is a very high velocity airflow coming from the top of our funnel. It spreads out immediately from the top of the funnel. If this ball goes up into the front of this funnel like this, it has a lot of air blowing around it from the top. High velocity of air gives us low pressure. So there's a low pressure actually at the top of this, whereas regular air pressure is all around us. And regular air pressure is much higher than the lower pressure air that's forming around here from the high velocity of airflow. So the higher pressure air from around an atmospheric pressure keeps this ball in place. A small styrofoam ball, a funnel that is connected to an air blower, and let's prove that we're actually
Seria interessante calcular esse 71 aí, né? Para mostrar com o reservatório, a gente poder adaptar um problema desse tipo para engenharia, com cálculo diferencial. Outro problema que poderia também tentar se utilizar o reservatório de aquisição de dados seria esse problema 39, que é o salto hidráulico. Talvez algumas adaptações aqui para a gente poder calcular a questão aqui da vazão volumétrica, né? Calcular aqui os raios, né? Então talvez seja interessante também.